Let's see what we got going on in this example. It says, consider an object moving along a line with a given velocity. So this is our velocity equation over an interval 0 to 5. So assume time t is measured in seconds and the velocity is measured in meters per second. So determine when the motion is in a positive direction and when it is in a negative direction. So for a positive direction, we need to know when the velocity equation is positive and when the velocity equation is negative. So we are given, V of t, and don't forget that V of t is the slope equation for our original position. So a positive direction is going to represent a positive slope, which is a positive velocity. So i.e. the slope equation. So we don't have to do a derivative or anything. We have that. We don't know the position function. We do know the velocity function. So we're going to take this velocity function. We're going to find some critical points. I'm going to set this equal to 0, and I'm going to try to solve it. So at the meantime, I'm going to factor out a 3 while I'm setting it equal to 0. So then that's going to be t squared minus 6t plus 8 equals 0. And then let's factor, find our critical points. Those are going to be the critical points are going to be when we transition from positive slopes to negative slopes potentially. So things that multiply to 8, add a negative 6. We're looking at a negative 4 and a negative 2. So solution-wise, we're getting a 4 and a 2. So let's throw those critical numbers onto a number line. And so each of these sections are going to represent different velocities. So if I plug in a 1 into this, I could plug a 1 into this, or I can plug it into this. And I just need to know my signs. So if I plug in a 1 into this, I would get a positive times, if you plug a 1 in here, you get a negative. Plug a 1 in here, you get a negative. And if you multiply those values together, you're going to get a positive. So that whole section would have positive velocity. And then we would shove, I don't know, let's plug a 3 in. So if we plug a 3 in, we would get a positive, negative, positive. So that would be negative slopes, which is negative velocities. So we'd have in a negative direction. And then here, if we plug in a 5, we get a positive, positive, positive. And so that whole section would be a positive. So where do we have positive direction? We have positive direction from negative, we were going from 0 to 5. So from 0 to 2. All right, we can't include 2 because it has a 0 velocity, so it's not moving at that point. However, at 0, if you plugged 0 into it, you get a 24 for your velocity. So right away, this object was moving. And so we would include it because it has positive direction. And then from 4 to 5, and we cannot include 4 either, just like we could not include 2, because at 4 you have a 0 velocity, so it's not moving in a positive direction or a negative direction. And then it stops at 5, but 5 would be included because it'd be part of this continual of a positive velocity. And you could plug 5 in and actually calculate it, and you're going to get a positive velocity. All right, and then for a negative direction, you're looking between 2 and 4, and neither of them should be included. All right, so that is finding your direction. Find the displacement over the given interval, which means we're looking for the total area under this curve. So how far did this object move? So we're going to go for displacement is not worrying about positives and negatives, letting it take care of itself. So we're going to do the antiderivative of this, 3t squared minus 18t plus 24 dt. And so if we do our antiderivative, we're going to add a power, divide by that power, 3t cubed divided by 3 minus 18t squared divided by 2 plus 24t. And we're going to go from 0 to 5. So let's plug it in, or I guess we should simplify this here a little bit. Let's do a t cubed minus 9t squared plus 24t from 0 to 5. And we plug in 5. We're going to do 5 cubed minus 9 times 5 squared plus 24 times 5. And then if you subtract, we're going to be plugging in 0. So that's just going to be 0. And so we would have 5 cubed is 125. 9 times 25 is 225. And 24 times 5 is 120. And if you add those pieces all together, you're going to get 20. And you're talking about a displacement, so you're talking about a distance on this one. And so we would have been 20 meters. So again, if you're looking at directions on things, you had positive velocity, then negative velocity, then positive velocity. So you were heading in to the right, you were heading to the left, and you're heading to the right. So after you put all that together, you'd be 20 meters to the right from where you started. All right, and then, but total distance was, we traveled to the right, we traveled to the left, and then we traveled to the right. So how do we figure out that? So this is us actually going back and figuring out these breaks right here. We have positive, we have negative, we have positive. So what we're looking at is some sort of a quadratic with x-intercepts at 2 and 4, positives, negatives, positives, and we're going from 0, so we need to figure out that area. And then we're going to stop at 5. So we need to figure out that area, and we need to figure out that area, and basically find that area, and find that area, but make that area positive. So the math for this is we're going to be going from 0 to 2 of our velocity function. And we're going to be adding the absolute value from 2 to 4 of that velocity function, plus 4 to 5 from the velocity function. Now, good news is we have our antiderivative. It's right here. So if I plug in 2 into this, that math right there would add up to 20. And I'd be subtracting 2. So you would basically have, you'd have 2 cubed minus 9 times 2 squared plus 24 times 2. So this piece would turn into 20 minus 0 for that section. And then when you were to go and plug it in here, you'd be plugging in the 4 into it. And then we already plugged in the 20, and it's going to give us a 2. So you'd be plugging in 4. And if we plug 4 into that. So for plugging this in, I have a bit of an idea to maybe we can shortcut this a little bit. Since we're going to be plugging in a bunch of different numbers into this, I'm going to go ahead and put in this equation into it and go to the table. And if I plugged in 0, we get a 0. If we plugged in 2, we got a 20. So we did that, 20 minus 2. If I plug in 4, we get 16. So then we're going to get 16 minus 20, but we're going to be taking the absolute value of that. And then plus, if I plug in 5, 5 is going to be right there. So 5 is 20 as well. So we'll get 20 minus the 4 plugged in, which was 16. All right, so we get a 20 plus 16 minus 20 is negative 4. The absolute value of that is 4. And then we get a 20 minus 16 is 4. So our total distance traveled is 28 meters. So we went to the right 20. We ended up going to the left 4, and then we went to the right 20. And that's, if you do that math and you treat it like that, we went 20 meters to the right, but overall that total distance was 20 meters because we ran to the right, ran to the left, and then ran to the right. All right, so that was a bunch of different problems, integrating, finding positive directions and slopes, but then also finding areas under curves and finding a total distance and a bunch of different things kind of all merged into one problem.